Good evening, all. I welcome you all to the Characterization of Construction Materials NPTEL course week 6 live session. So, I am Nilakanmani. I am a PhD scholar working in the area of construction materials. I work on biomass ash I work on how to make a binder out of biomass ash, and I have worked on this characterization technique. So, today we'll be discussing about the surface area measurements. Okay, so I hope you guys have successfully submitted last week assignment, and I wish you guys have watched the video of this current week assignment for week 6 surface area measurements, and you guys have to submit the assignments by Wednesday, and tomorrow you guys will have one more live session. Okay, let me let's move to the first question. Yeah, hello. Okay. If someone needs to say something, you can unmute and talk to me. And if I'm not audible, please stop me by any point of time and check. Okay. 1 minute. Let me check whether the audio of the video is still recording. Okay. And to the people who have joined new, let me introduce you to codes. To the bottom right corner of your screen, there is an option called activities. Okay. If you're using a mobile phone, you can click these three dots. There you can find these activities, and you'll be directed to codes. If you click these activities, you will find that with different options. Out of that, you have to click polls. Then you can find the questions launched. You need not answer the questions right away now. So you can wait. Once we discuss the question in the PPT, then you can come here and give your answers. Okay. And if you have any other query regarding uh, the current assignment questions or previous week questions, we can discuss the concepts here, but not the solution. Okay. Now we get back to the PPT. Let's move to the first question. If it's a multiple choice question, you can give the answer in polls. But if it's a multiple select question, then you have to give the answer in chat box. Okay. And you have mentioned here where you have to answer. Answer in polls is in most it is multiple choice question. Okay. So first question is the true or false question. Here is a statement. Refractive indices of sample and dispersant medium are required for reliable measurement of particles distribution using laser diffraction. Okay. So in laser diffraction technique, whether we need refractive indices of the sample as well as the dispersant medium. Okay. Whether we require both, just choose the right answer. Let me start the timer for a minute. If you're not able to give your answer in polls, you can give your answer in chat box. There are different techniques to measure the surface area. Out of that, one is laser diffraction, and laser diffraction also there are two different theories from which we can measure uh, particle size distribution. So you have to think and you have to give your answer. Here they have given the word reliable measurement. Time's up. Let's see the class response. Okay, option A. Okay, most only one answer have been given. Okay, fine. Try to give your answer so that you guys will get to know you you get to involve with the class so that it will be beneficial for both of us. Okay, so the correct answer is true because we need if it there are two different theories, Fraunhofer theory and my theory, and my theory takes in account of the optical properties of both material as well as the medium. Both refractive and absorption indices are required. Refractive index we can get from literatures also, but absorption indices is difficult to find. So normally, even when I measure refractive index, sorry, for particle distribution of ash materials, I was able to find the refractive index, but finding absorption index is very difficult. Okay, so and we can measure a size range of 0.02 to 2000 micrometer uh, using my theory with laser diffraction. Moving to the second question, the particle size and specific surface area of cementitious materials will have influence on which of the following properties will be influenced by particle size and specific surface area. You can give an answer in chat box. One option A is hydration kinetics. Let me start the timer for a minute. Option A is hydration kinetics, and B is mechanical properties, and C is rheological properties, and option D is only A and B and not option C. Okay, so you have to find the right answer. Thinking about the particle size, if you have to increase the reactivity, does the particle size should be less or it should be big? So if the reactivity will be influenced by the particle size, and will it influence hydration kinetics? Just think, and as well as if there is more reactivity, will it really affect the mechanical properties? And also, if it is, think about the when it comes to electrical properties, maybe we can, to simplify that, maybe we can think in the terms of if it's very fine, then the water demand will be increased or decreased. In that case, you can think and give the answers. Are you guys still giving the answer? About five people are in the class, it seems. At least I want four of you to give the answer. If everyone gives the answer, I'm really, really happy and glad. Let's see the class response. Option C. Okay. Let's see the correct answer now. Thank you. So, can someone unmute and tell? Let me if the particle size is small and if a particle size is large, where there will be more, and consider 2 grams of material. Okay, sorry for this poor writing. And for the same 2 gram, the number of particles will be pretty high, right? Make it up to 2 gram. Okay, where the surface area will be more, first case or second case? Please unmute and tell me, or you can type in the chat box also. But unless I have to join see the Google Meet chat box. So if someone can unmute and tell me, it will be fine. The mass of the sample is same, but here the particle size is different. Which one will have more specific surface area? It's pretty simple. It's very, very easy. Okay, let's see. Let me see the chat box. Sometimes you guys used to give some answer in chat box. So am I audible to all? The question is very, very difficult.
Yes, ma'am.
Yeah, okay. Thank you. Thank you, Javed. Is the question very difficult to understand? Fine. How many of you watched the videos? No answers.
Total video, ma'am.
Sorry?
Total video, ma'am.
You watched the video.
Yeah, ma'am.
Okay. Okay. Thank you, Javed. Uh, so, okay, leave the video. As of now, I'm simply asking. Okay, maybe surface area you might not be able to understand. Surface area is the area around the particle. Let's assume a, sorry. So, see if it's a sphere, used to calculate the overall area, right? Take a big sphere and a small sphere, and which one will have more specific surface area? If you take and calculate, if you take 2 grams, the number of particles here, if it's only one, about 20, say about some 25 plus particles should be there to make up the same mass, right? 25 plus. Okay, so in that case, if we calculate this, the specific surface area from the small particles will be more. If we calculate and see, maybe if in that case, maybe you can think about uh, same volume of material, but the maybe first easiest case, maybe you can think of a square. Okay, take a yeah, we can think about square, then it's easy to think, I guess, for you guys. So let's take a cube, okay, of 4 centimeter. So similarly, we are taking here, here is only one number, okay, but here we are taking 8 numbers and making up the same square. Similarly, here again it will be there. Okay, so totally there will be 8 numbers here, up top 2, and then bottom also there will be, so totally here 4, and then back 4. So 2 plus 2, it will be 4 centimeter, right? Here it's 2, 2, and here it is. Let me take an eraser. Here again it will be 2, 2, right? So end of the day, the volume will be same, right? If you measure, what is the volume of this cube? Cube of size 4 centimeter. What will be the volume? Use calculator and tell me. Use your mobile phone and tell me. 4 into 4 into 4. So volume, right? Volume of cube. A cube. A is 4 here. What is the volume of this cube here?
Ma'am, you can formula is 4 by 3 by R cube, na?
Yeah, yeah.
Okay.
So uh, what is the volume of cube of 4 centimeter or 4 units? What will be the volume?
64, ma'am.
Yeah, 64. Fine. Thank you. But in the same case, here we have 8 numbers of 2 centimeter cubes, right? So similarly, what is the volume of 2 centimeter cube? 1 cube. Tell me 1 cube, then we'll multiply by 8.
It's 8, ma'am.
It's 8, right? So, okay. So end of the day, the volume is same, right? 64, 64. But when it comes to surface area, let's calculate the surface area now. So what is the
More,
surface area?
more the number of particles, ma'am, the surface area will be more, ma'am.
Come again.
More the number of particles, ma'am, the surface area will be more, ma'am.
More number of particles saying that to the same volume of matter, if the particles are very small, see, then if the way you said, the concept is right, but the way you said is not reachable to everyone. So in that case, if we have a, let's assume having a ball of 10 centimeter dia, and same volume of balls is taken, but the size is only 1 centimeter, then the surface area from the smaller balls will be more. The specific surface area from
Simple,
all the balls
in a
will be
simple
more
way,
than.
in a simple way, if you want to explain, ma'am, the easiest method is we can take the example of groundnuts and soya chunks, ma'am. If we
Okay.
take of same weight, say for example 100 grams, the number of ground nuts in that 100 grams will be more
let me
than the
let
soya chunks.
let me tell one thing. If you take a two different material, then the density will be different.
No,
Then
I'm
the
talking about the
mass will
particle
be,
size, ma'am. Basically,
yeah.
the
If you
particle size.
take, yeah,
The particle size will be small in groundnuts and it will be more in quantity, whereas in soya chunks, the particle size will be big and it will be less.
yeah,
So
sure.
the surface area which is required to polish or to cover the entire groundnuts will be more as compared to the soya chunks.
Yeah, sure, correct. You know, also we can compare coarse aggregates and fine aggregates. The specific surface area from coarse aggregate will be small if we take the same mass of fine aggregates, but the specific surface area from the fine aggregates will be uh, higher than the coarse aggregates. And if we take SCMs like fly ash or cement, then obviously the specific surface area from the cement will be even more higher than the fine aggregates. I hope now you guys can relate what we talked about. So here in that case, the specific surface area from smaller particles will be more even if the mass is same. Okay. So now I hope you guys got it right. So in that case, will it not affect the hydration kinetics? If it has more specific surface area, then there will be more dissolution from the all the surfaces and more reactivity will be there. No, then it will affect the hydration kinetics also. Not only most of you have selected rheological properties, but it will affect hydration kinetics. And if there is more reactivity and better particle packing because of the smaller particle size, then the reactivity as well as the particle packing both will uh, impact the mechanical properties as well. Okay, better particle packing will give better mechanical properties. So in that case, it will affect rheological as well as mechanical properties as well as the hydrogen kinetics will be affected. If you take particle size, here they have given this snap is from lecture only. So if you take heat evolution from a cementitious material, if the size is 6 micron meter, then the heat evolution is higher. If you take 5 to 13, then it is in this range. And if the particles is pretty higher up to 38 micron, then the heat evolution is pretty less. So in that case, you can understand that the particles is also will impact to the reactivity. That's why we are measuring the specific surface area of the particles as well as the particle size distribution as well. That is that's why we measure. Or else there is, if it doesn't impact any of these properties, why we are going to measure the specific surface area? Okay.
But
So
ma'am, the
now,
option D says it is like
yeah,
option A, B, C were right, proper. Actually, all the three were right. But the first instant which came to mind was rheological properties because anything which starts in with cement, the first thing is rheology property, ma'am. That is basically the workability, the flowability of the mix what we are doing. Then only the second part come. But okay, ma'am, all the three are right because it doesn't say what are. So I thought of only one answer.
yeah, good. Thank you. I hope you got it right. So, and basically, if it's MSQ, then it has more than one right answer. It's a very simple trick to find that we have more than one right answer. Okay. So, and it's easily differentiable in the assignment questions also, which one is MSQ and which one is MCQ. So, there will be circular, the options will have circular things to tick if it's a MCQ, and it will be box shaped things to tick whether if it's an MSQ. More than one option is right, then there will be rectangular boxes to tick. Okay. So now, but I'm not sure about the final exam. Okay. Uh, so here the third question is here. It's based on particle size measurement only. Which of the following particle size measurement techniques is not suitable for particle size less than 50 micron meter? Okay. I'm starting the timer now. So here are the options. Option A, sieve analysis. Option B, Fraunhofer theory for laser diffraction method, and my theory for laser diffraction method, and then nitrogen absorption using BET method. So the following particle size measurement techniques is not suitable. And it's an MSQ. It has more than one right option. Please pick the right one. Time is up. Let's see the class response. Okay, A and B. A, B, B. Okay, fine. Let's see now. Let's see the solution now. So when it comes to particles is less than 50 micron meter, both Fraunhofer theory and sieving is not suitable to measure, because in Fraunhofer theory it doesn't take it is measured from the wavelength of light, so it's not suitable for particles smaller than 50 micron meter. And then when it comes to sieving also has more difficulties in cleaning the sieves, and so it's not easy to measure the particle size with sieving, so it's not suitable for uh, uh, it's only suitable for fraction larger than 50 micron meter, and it's normally suited for larger fraction. Okay, so now can, and most of you have picked the right answer, I guess. Both A and B have chosen. Someone have given A and someone have given B, but the right answer is both A and B. Okay. Now let's go to the next question. Question number 4. The question is, the duration of sonication does not have influence on particle size measurement using laser diffraction. So normally we have agglomerates, right? uh, if it's a very fine particle, say silica fume, there will be more agglomerates. If it's a very fine material, like even fly ash, if it's finely ground, there can be agglomerates in the particle. So normally we do sonication before measuring the uh, particles distribution using laser diffraction. But here the point is, we know that we are doing sonication. But here the point is, the duration of sonication is the parameter. Does it have an influence on particles measurement? Here the statement is, it does not have influence. Please pick the right answer. Let me start the timer for a minute. I request everyone to give your answer. It's a very, very simple question. Time is up. Let's see the class response. Option B. Okay. Okay, it's already launched in post, right? Again, right answer. Sorry. So here, this snap is from the lecture PPT. So here we could see that when there is no ultrasonication and there is 2 minutes ultrasonication, 4 minutes and 6 minutes, we could see that there is difference in the D10, D50 and D90 size measurement. And mostly D10 measurement is not much varying, though there is some small variations. But when it comes to D50, obviously, when there is no ultrasonication, then there is 2 minutes to 4 minutes, and there is 6 minutes, they could see a slight difference in the measurement. And when it comes to D90, we could see a major difference in the size measured. So the time of duration of ultrasonication also impacts the particle size measurement. So the correct answer is false. Now, most of you given the right answer. Now, let's move to the next question. So, now we move to nitrogen adsorption theory. So, here the question is, nitrogen adsorption theory relies on uh, adsorption of gas molecules on the surface of particles. Either it's physical or chemical or both. Okay. So in nitrogen adsorption theory, we know that we purge, first we put the material under vacuum for a certain period of time at a higher temperature, and then we purge nitrogen gas, and then we it undergoes adsorption over the sample or material of interest. So what kind of adsorption happens? Let me start the timer for a minute now. It's physical or chemical or it's both. Please give your answer in polls. It's already launched. Okay. Let's see the class response. No oats. Okay. Option A. Let's see what's the right answer. So here the correct answer is gas molecules are physically adsorbed onto the surface of the solid. Okay. If there is some chemical adsorption, then the property of the material can vary. So here we don't want any reaction between nitrogen and the material of interest. So here normally nitrogen adsorption gas is not reactive. That's why we use nitrogen gas for adsorption. So the gas molecules are physically adsorbed. The correct answer is physical adsorption. Hope you guys got it now. So now let's move to numerical problem. Now to calculate this physics surface area, if the average diameter from DET method is 23 micron meter and the density is 2 gram per cc, okay, grams per centimeter cube, we have to now calculate the physics surface area. I know that you might not be able to remember the formula, so I'm showing the formula also here. Okay, so here this is the formula from the lecture. dBET, its average diameter uh, will be equal to 6 divided by specific surface area multiplied by density. So if we rewrite the formula, it will be specific surface area will be equal to 6 divided by dBET multiplied by density. Okay, so I request you to calculate the specific surface area and tell me. The answer should be in centimeter square per gram. Can you guys calculate? Here the values are given, right?
Ma'am, I have one doubt.
Yeah.
Is average diameter is equal to the equivalent diameter?
See here, we are not talking about average diameter, equivalent diameter. Uh, Here we are talking about, we are given a certain value and we are given the formula. You have to apply the values given here and calculate the physics surface area here. Okay, equivalent diameter in the sense that is calculated. See, most in laser diffraction technique, it assumes a particle to be circular. Okay, but most of the particles are not circular. So in that case, they measure the equivalent diameter. That is a different phenomenon. Okay, here we are not talking about that. So here in that case, we know that the average diameter dBd is equal to 23 micron meter and then density. Rho is nothing but 2 gram per centimeter square. So here there is difference in the units used, and finally we want it in centimeter square per gram. So in that case, if we want to convert micrometer to centimeter, then 23 multiplied by 10 to the power of minus 4. In that case, you will get centimeter. Okay. So please calculate and tell me just the math. You just can substitute and get the answer. The formula is here, the values are here. Maybe I'll start a timer for 2 minutes. Okay. After 2 minutes, like, yeah, once you calculate, you can post the answer in chat box, or you can unmute and tell me. So already 1 minute is done. Has anyone calculated? Very, very simple, right? If you put it in a calculator, it's pretty simple to calculate, right? Why is taking so much of time? Okay, let's see the solution then. Okay, if there is some class response, let's check. Okay, 1, 3, 0. Thank you, Prasad. Someone has calculated. So here we know the formula, and then we have changed it. So here 6 divided by 23 multiplied by 10 to the power of minus 4. The same point. The 23 multiplied by 10 to the power of minus 4 and multiplied by 2, that is the density. So here we changed it so that we can get the answers finally in centimeter square per gram. And finally what we got is 1304.35 centimeter square per gram. And we want to change it into meter square per gram, then it will be changed. Okay. I hope you guys got it right then. Now let's move to the next problem. So here it's a very, very simple question, very, very straightforward question too. You have to find the formula to calculate specific surface area using a linear equation for nitrogen absorption, gas absorption experiment. Okay, here Na is nothing but Avogadro constant, and An is nothing but the area of surface occupied by a single adsorbed gas molecule, and V naught is the molar volume of gas. Okay, so now let me start the timer for a minute. It's a very, very simple question. I could not upload these values in chat in polls, so please give your answer in chat box. Which one is the right answer? Have PPT, you can just go through the PPT and give your answer. And there is a problem based on this formula also, right? We are given you data sheet, and then you have to plot the data, and then you have to calculate. Then you have to find out the slope of the things, and then you have to calculate Pm, and finally you have to calculate uh, specific surface area. So please find the right formula, and then I request everyone to do the calculation and then find the right answers in the current assignment problem. Time is up. Let's see the class response. Option B. Yeah, right. Thank you. The correct answer is nothing but option C. Okay. So Avogadro constant and AN is already given. And molar volume is pretty simple. Like if you Google, you will get it. Molar volume of nitrogen gas. It's very simple to get. And then the only thing you have to calculate from the data sheet is Vm. And if you calculate the slope and the intercept, then it's very, very simple. Okay. So now let's move to the next question. You have to identify the type of isotherm based on the IUPAC classification, IUPAC classification. So this is the graph. Now you have to find the type of isotherm. I have already given you the data. You have to find the type of isotherm also. So you have to plot the uh, absorption and desorption graph, and then you have to find what type does it fall into. It might not be the same as graph here, but like we have given you different types of right, up to type 6 we have given. It may not be exactly the same as a given thing, but it will correlate with at least one of the given isotherms from type 1 to type 6. So you have to find it. I've already started the timer. Please give your answer in polls or even in chat box. I request everyone to give answer for this question, at least for this question, because it's very, very simple one. Time's up. Let's see the class response. Okay, option D, option D. Fine. Oh, open the lecture PPT. Okay. So the correct answer is nothing but which one is matching? Type 4 is actually matching. So the correct answer is type 4. I think the graph, whatever given in the lecture PPT might be slightly different, I feel. Yeah, anyway, because there are type 4 is there is different things from A to B and C, I guess. But type 4 is there, the adsorption and the desorption graph will be slightly different. And there will be hysteresis loop here. So that's why we can easily identify type 4. And even if you see type 5 and 4 will be more or less similar. But here there is a different curve here. Uh, uh, there is a different curve here, and if you see type 5, the initial part of the curve will be slightly different from type 5 to type 4. You have to understand. And type 4 and type 2, if you see, the initial portion will be the same, but this hysteresis is not there. The path followed by adsorption desorption will be same. Okay, so the right answer is type 4. This is the last question. If you guys have any more question to ask, you guys can ask me. Or else we can leave the class today.
Ma'am, I am having one question.
Yeah.
What is the, how we can we find the equivalent diameter of a cube size particle?
Actually, I don't know the question, so it's very. I think that is a very simple question. I guess equivalent cube. So I think there the volume is constant, right?
Only the cube size is given.
Okay.
Equivalent diameter we want to find when the particle in the sample is a cube size of 3 nm.
3.
3 nm unit nm.
Okay. Micrometer or
Yeah, ma'am.
okay. Okay. Fine. So 3 micrometer is the size of the cube, right? One side of the cube, right?
Yes, ma'am. Yes, one side of the cube.
So there you have to keep the volume constant, right?
Ma'am, it will be
Volume
dia will be equal to 2 into area by pi, ma'am. To convert
2
the
into area by perimeter, no?
by pi, ma'am, pi,
Pi.
pi, 2 into area by pi. That will be equivalent to the equivalent dia.
Actually, I'm not
Thank
able
you,
to
sir. 2
understand.
into
Sorry.
area by pi.
Ma'am,
Okay.
actually, the other ma'am is trying to convert the there is a square or a cube which has been given and the area has been given or the size has been given, and she wants to convert that to a equivalent dia of a sphere, ma'am.
Okay.
So equivalent dia is equal to 2 into area by pi.
Wait. 2 into area will not come, right? The volume will play, right? If it has to be, it's a sphere, and if it's a cube, then volume comes to play the role. Then you should not use a square and circle. Then you have to think about a cube and a sphere, right? Then you have to take volume. Or am I speaking it wrong, or I don't know. Because I didn't
I-
go through the current assignment
I'll
problem
check
case.
once again, ma'am, but the Google says it is d is equal to 2 into area by pi only, ma'am.
But
Okay.
when I searched, ma'am, I got another equation saying that 4 into area divided by perimeter.
Okay. Let me stop presenting now and let me look at the current assignment problem just a minute.
Okay, ma'am.
Yeah.
That means the sphere volume is equal to the area, cube volume, and we have to find the diameter of the sphere.
Uh, I'm saying you have to consider the volume to be constant. Okay. Then you have to calculate which equation you have to take, which
Okay, ma'am.
equation you should not take. I can't clearly explain, but the concept is the volume will be constant, right? In that case, if you
Okay,
have to yeah, then you have to take the equations.
okay, ma'am.
Yeah. Is there any more query?
Ma'am, there's a article, ma'am. If Meghna ma'am wants to go through that,
Yeah.
the heading is two particle characterization, ma'am.
Okay. Someone is helping you, Mena. Please follow that.
Two particle.
Maybe you can type in the chat box, Rao.
Okay, ma'am.
Yeah. Sure.
Just have a look at this PDF, ma'am. I think there's a numerical also given in this, if I'm right, ma'am.
Okay. Okay.
Thank you, sir. Thanks a lot.
Welcome, ma'am.
Yeah. KPC, you have taken advanced concrete technology also.
Yes, ma'am. Cleared it, ma'am.
Okay. I just remember this name somewhere. Yeah.
Yes, ma'am.
Okay. You've taken concrete technology also.
Advanced concrete I did, ma'am. Now I'm doing this.
Okay.
This
No,
one.
no. You took concrete technology also.
No, ma'am. Only advanced concrete, ma'am.
Okay. Fine.
Thank you, ma'am.
Is there? Yeah. Thank you, Ram. Is there any more query? Okay, fine. I request everyone to watch the videos and come for the live session. Unless you watch, it will not be helpful even if you sit here for a hour. So I request everyone to watch and come for the live session. And tomorrow you guys have one more live session. Please attend that too. Thank you. If you are free to attend. And there can be repetition of questions also. So make sure you attend the live stream whichever is the time is comfortable for you. Let me end the live session now. Thank you all. Thank you for being so patient.